Dear students of 9th standard, welcome back to the class. Hope you have understood the previous questions well. If you have any doubts in the other chapters, presently we are doing quadrilaterals, exercise 8.2. We are in question number 6. If you have doubts in any of the other chapters also, please let me know so that I can make videos for you. Thank you. Let me proceed with the question. Question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. There are few cases where the diagonals bisect each other. In a parallelogram, the diagonals bisect each other. In a rhombus, the diagonals bisect each other at right angles. In a rectangle, the diagonals bisect each other. In a square, the diagonals bisect each other. So, we need to prove that it's a parallelogram. The figure joining the midpoints is a parallelogram. So, let me go to the question. See what is given in the question. So, let me draw a parallelogram, a quadrilateral. Let me draw a quadrilateral ABCD. ABCD is the quadrilateral. Let the midpoints be PQRS respectively. Now, let's join the midpoints PQRS. Now, first of all, let me draw the diagonal. In all these questions, children, you remember that you have to draw the diagonal. So ACD, first let me take the triangle which is above the diagonal. ACD, S and R are midpoints. The line joining the midpoints is parallel to the third side and also half of it. So therefore, SR is parallel to AC and SR is half of AC by the midpoint theorem. Now let me take the triangle which is below the diagonal AC. Now we know P and Q are midpoints. The line joining the midpoints is parallel to the third side and also half of it. So PQ is parallel to AC and PQ is also half of AC. This is our statement 1 and statement 2. In both of them, they are equal to half of AC. So you can say that SR is parallel to PQ and SR is also equal to PQ. One set of sides parallel and equal. What is the figure PQRS called? One set of sides parallel and equal. It's a parallelogram. And we know that the properties of a parallelogram, which say that the diagonals bisect each other. Correct? That means the points where we are joining the midpoints of the sides, PQRS becomes a parallelogram. Wonderful. Let me go to the next question. Question number 7. We're coming to the end of the exercise. So students who need some assistance in other chapters, please let me know so that we can do those exercises also. Tiwari Academy, it's a very good website where you have the solutions also given. Let me read the 7th question. ABC is a triangle, right angled at C. So the right angle is angle C. A is a line drawn through the midpoint M of the hypotenuse AB and parallel to BC. This line is parallel to BC. Intersects AC at D. It intersects AC at D. Show that D is the midpoint of AC. So let me go one by one. Let me take only the first part. In this particular triangle, ABC, M is given that it's a midpoint. It's also given that MD is parallel to BC. So by the converse of the midpoint theorem, what does it say? D has to be the midpoint. It bisects the third side. So what is the third side? AC is the third side. So D bisects AC. That means D is the midpoint of AC. So the first part is proved. Now let me come to the second part. That is MD is perpendicular to AC. MD, where is MD? MD is here. MD is perpendicular to AC is given. We know the properties of parallel lines. What does it say? We know that DM is parallel to BC, correct? DM is parallel to BC and angles ADM and ACB are equal. Why? They make corresponding angles. Already angle ACB is 90 degrees. So now angle ADM is also 90 degrees, which proves that MD is perpendicular to AC. So our second part is also proved. Now coming to the third part. CM is equal to MA is equal to half of AB. Oh, the CM and MA. That means CM and MA equal to half of AB. Let me take the triangle, the two triangles. Let me draw the triangles once again so that there's no confusion. Yeah, we have these two triangles. All right. This part is already AD is equal to DC. We know that DM is common and we have ADM, and since it is perpendicular, ADM is equal to CDM, 90 degrees. So right angle, which one you have to say? You have to take SAS. Sides AD and DC are equal. DM is common and the angle between the two sides are equal. So by SAS, side, included angle and side, the two triangles ADM and CDM are congruent. So what can we say? Now the corresponding parts of the congruent triangles are equal. So therefore we can say that AM is equal to CM. But M is the midpoint, right? So M is the midpoint and AM is equal to MB also. So CM is equal to MA and MA is half of AB. Hence it is proved. The third part also. Thank you.